Optical helmet tracker systems for helmet-mounted display and sight systems are based on 3 cockpit-mounted camera sensors observing distributed, distinct light sources located in the pilot's helmet. For the system to operate correctly, the position as well as the roll, pitch, and yaw offsets of the various sensors relative to each other and relative to the aircraft reference system must be known. In close cooperation with SAAB Aeronautics, Metronor has developed MIL standard system for calibration of the SAAB Gripen helmet tracker devices, determining their orientations and positions in all 6 degrees of freedom. The system comes in 2 sturdy, customized MIL standard storage and transportation cases. And consists of the following main components: the laptop hosting the applicable software and providing power to the system components during operation, an external camera used for picking up the aircraft coordinate system, a cockpit camera used for determining positional and angular relationships between helmet tracker brackets inside of cockpit, an aircraft reference pad assembly picking up the aircraft coordinate system, 4 mini platform pads, 2 for the single-seat aircraft and 2 for 2-seater used for picking up tracker bracket geometries. Let's follow the calibration process. Prior to installation of the calibration system components, the 3 cockpit camera sensors must be removed in order to provide access to their mounting brackets. The sensor calibration data are referenced to the brackets' positions and orientations relative to each other as well as to the aircraft coordinate reference system. The system computer is now booted and the applicable aircraft data is recorded by the operator. The computer system holds software that will guide the operator through the whole installation and calibration process by easy-to-understand, self-explanatory graphical displays. The second step is to install the LFD pad, which picks up the aircraft reference coordinate system. Thereafter, the LFD pad is connected to the computer. Then, the right and left hand mini pads are mounted onto the respective cockpit camera sensor bracket. Likewise, the cockpit camera is mounted onto the forward cockpit camera sensor bracket. After installing all the various system components, the remaining cables are connected. The system is now ready for data recording. The first stage is for the system to run a built-in test which automatically verifies the integrity of the various pads and that the external camera is correctly positioned relative to the aircraft. Green tick marks indicate that the system is ready for the actual measurement process. During the next cycle, the external camera is recording the spatial relationship between the aircraft reference coordinate system and the local coordinate system of the left-hand cockpit camera mount. This part of the calibration process is all done with the canopy in the open position. The operator is now guided by the system to close the canopy. The computer shows a live picture from the cockpit camera, enabling the operator to verify that the camera is correctly mounted and that the pads are fully operational. The system is now ready for the last measurement cycle. The cockpit-mounted harmonization system camera will view the two mini pads, and the system will record the local coordinate of the forward cockpit sensor bracket relative to the local coordinates of the right and left cockpit center mounting brackets. Thereafter, the system will automatically transfer the 6 degrees of freedom spatial relationship between the respective cockpit center mounting brackets into the aircraft reference coordinate system. The external and internal measurement cycle is completed in less than 5 minutes. As a final step, the measurement report is saved and printed for transfer of offset data to the aircraft computer.